Hello and welcome to our ROS 101 Fun Approach tutorial delivered to you by Sammer. So let's have a quick recap on what we did so far in this course. We learned how to use some ROS utilities such as publishers and subscribers. We created our own publisher subscriber package, and we learned our business model of teamwork, which included a number of nodes where each node is either a publisher or a subscriber, or maybe a publisher and a subscriber at the same time. And these nodes work cooperatively to achieve a number of tasks, and they communicate with each other. So each node is continuously working on its task and publishing its results or subscribing to the results of another node. So these nodes are running continuously. And we began to get used to the terminal, so we used the terminal multiple times, and we typed a couple of commands, and we're getting used to the terminal, and we're beginning to get somehow convinced that the terminal is more efficient than a GUI in multiple applications. And we were also introduced to Python, so we use Python to develop our applications so far. So we're beginning to, get introduced to Python bit by bit. And we played with a turtle. So we worked in a simulation of a kinematic turtle, and we defined what a kinematic simulation is. So that's what we did so far. So today we're gonna be introduced to a new business model that is different from the publisher-subscriber architecture. So suppose that you are asking for a service, like you are some business owner who's trying to, hire a freelancer or some contractor to do a certain job, and that's it. So that's quite different from the publisher-subscriber architecture, which we talked about before. Because a publisher-subscriber architecture, you have a team that is continuously working on their tasks, and this is like a situation where you have a number of employees working on a permanent basis, unless they decide to leave the company, of course. But here we're trying to, ask for a service, and this is where we need some client-service architecture or client-service business model. So what we're going to do today is we are going to introduce like ROS services, which is, as we said before, is a new business model. And we are going to create our own client-server package. And then we're going to elaborate on the difference between a publisher-subscriber architecture and when we should use a client-server architecture and when we should use, the usual publisher-subscriber architecture. So let's dive in. So what I'm going to do here is try to elaborate on the different architectures we have in a ROS package. So we got introduced already to the publisher-subscriber architecture. So here, let's just say we have a publisher here. I'll denote it using a P, and a subscriber, which I'll denote using an S. All right. So we said before that we have a topic here, which represents the channel or the buffer, which links publishers and subscribers. So we said that, for example, a publisher just executes some task here and then stores the result in a topic or in a topic channel or a topic buffer. So what a subscriber does is that here, like for example the YouTube business model, what a subscriber does is he subscribes to the channel or the topic in this case, and whenever there's a new message, the subscriber just retrieves this new message. So here we can say that a publisher does not necessarily need a subscriber, and a subscriber does not necessarily need a publisher. So all what we have here is we have a topic. So a publisher might, just publish to a topic and there might be no subscribers. For example, someone who's opened up a new YouTube channel, so he is publishing content but no one has subscribed yet, but the content is still there waiting for someone to view it or watch it. And what's different here today is that we need like some client here. So we're gonna denote this by just typing client, right? And we have a server. So in order to differentiate between the server and subscriber, I'll just type here like server, right? So what a client does is that it requests for a service from a server. So a client cannot receive a response unless there is a server. So if I'm asking for a service and there's no one to do this favor for me, then I cannot issue like this request. Or I may be able to issue a request, but I'm not really expecting to have a response. So what we need to know here is that each client needs a server in order to start running. So if a server does not exist, or if my server does not exist, then I will not be able to proceed with my code. I will not be able to execute my task. So that's the first difference between the two architectures. So here, instead of a topic, we have a service, which represents kind of the channel of communication between the client and the server. So here we have a service. So what the client does is that it issues a request. So this request passes right here to the server through the service. So this is my request. And there's also something different here, is that a publisher and a subscriber do not need to, provide some feedback regarding the object that was received. Like the subscriber does not need to inform the publisher that his task was magnificent, for example, or his task or his content was cool. Someone might watch a YouTube video and decide not to leave a comment or not to like that video, for example. But here in the client-server architecture, which is more of a business relationship between two entities, the server must provide some feedback for the client. It must provide, therefore, something called a response. So I'll just type RISP, and that's short for response. So what happens here is that the client issues a request, which is processed through some service here, and the server receives this request and then begins to execute some task which is related to the request the client has issued, and then it provides a response which might be, for example, the outcome of the task and some feedback regarding this outcome. Did I succeed? Did I fail, for example? If I succeeded, if maybe there is some feedback that I want to issue to the client, like for example, if I'm developing a product for the client, then I'm just informing the client of how to use the project, for example, how to use this product. So yeah, there must be some form of a response. So that's the theoretical part of our argument today. So let's get to the coding and let's see how this all works in reality. So here's my screen now. What I'm going to do is that I'm going to navigate to my package, which is the Catkin workspace. Oh, sorry, navigate to my workspace, not my package, Catkin workspace. So here I am in my Catkin workspace, and I'm going to the source file, which is the file that's concerned with all the code that I'm writing. The other files, as we said before, are responsible for the build operations and storing some data or some information on my package. So what I'm going to do is I need to create a new package for my client-server application here. So I'm going to open the terminal from here, and I'm going to catkin create package. So I'm going to type catkin create package, and then I'm going to call it like Client-Sever, for example. To be straightforward, it is yeah, Client-Sever. Right, so I created my package here, and as you can see, the files associated with the package are here. So what I'm gonna do is that I'm gonna build my Catkin workspace. So I'm just gonna open a new terminal here for just build operation, and I'm gonna type catkin build. Alright, my two packages were successfully built. So I'm gonna head to the Client-Sever, and I'm gonna, open up a scripts folder. As we said before, scripts is like our own standard of, assigning folder names and stuff inside my package. It's not obligatory, but you need to do it just to make your package neat. So I'm gonna open up my scripts, and well, you can just navigate from the terminal here. So I'm gonna go to first of all, I need to go to the package. So let's type Client-Sever here, and maybe just add, well, I'm kind of, well, let's just type it all over again. CD, I'm gonna go to the Client-Sever package and scripts. Alright, maybe alright. So here I am. I need to create a new script. So let's just start with the server code or the server script. So I'm gonna type like touch server.py here. And of course it's py because I'm developing a Python script. So let's just, have a quick recap on what we did before. For example, here the server will pretty much resemble a subscriber, at least coding-wise, because the subscriber functionality-wise is more like, the publisher, since it's the one that provides the outcome of a certain task. But coding-wise, you'll find that the server is quite similar to the subscriber. So let's just begin with the things that are similar, or quite the same actually. First of all, I'm gonna pick my development environment, or my Python language, or Python language version. So I'm gonna type user bin environment, and I'm gonna select Python 3. As we said before, this line is to inform my my compiler that I'm using Python 3. So I'm referring to the location of Python 3 on my device. So what I'm gonna do is I'm gonna import some of the usual libraries, of course, import ROS, and also I need to import the data type that I'm gonna use. So when it comes to messages, we used to, for example, if I'm using integer 16, for example, I used to say from standard messages.message import int 16, for example, assuming it's not an array, assuming it's just a number. All right. So what I did next is, for example, I start by initializing my node. So yeah, let's just pick a name for this node. So rospy init node, and I'm gonna call it, just service, like this, or sorry, let's just call it server here. And you can call the Python file and the node the same. You can use the same name for both the Python file and the node, so it doesn't make quite a difference. Actually, it's quite easier for them to have the same name, at least for me. So Yeah, and we said that we have named our nodes. So next thing is I'm going to, for example, create my subscriber. So what we used to do is we say rospy.subscriber, and we fill that with a couple of stuff. So first of all, there was the topic name, so I'll leave that like blank for now because we're not really using a topic right now, but I'm just starting some argument on the similarities between the two architectures. So, and you just use the data type, for example, in 16 here, and then use the callback function. Of course, you define your callback. So I'm gonna type callback here, and that's pretty much it. And then I'm gonna define my callback function here. So I'm gonna, just type define callback, and I used to receive a message. So I'm gonna, type message here, and then here's my callback, and I'll leave it blank for now. So, and what you do last is that you just type rospy.spin in order to make the code freeze in this line. It's just like some while loop here. Well, like it's a ROS while loop, so it's better than using the usual while loop. While you have two functionalities that for example, a functionality that's already available in Python, and another function or another object that does the same function in ROS. You pick the ROS option because that will be more efficient. Alright, so I'm just gonna use rospy.spin here, and that's it. So what are the differences? Let's discuss the differences now. The first difference is I'm not using a message anymore. I'm using a service. So what I need to do here is that I'm going to define a service. So let's just check out this service thing. As we said before, anything related to communication or ROS, we'll find it in our ROS installation here. So I'm going to go to opt, then ROS, and my version, which is Neotic, and then the share folder, which is responsible for all the messaging and the communication stuff. So let's just check something called standard services. If you remember, we used to check standard messages here, so you'll find that its cousin, which is standard services, is right here. So let's check our standard services. So I'm gonna go to service, SRV, short for service, and then I'll find three types of services. So let's, for example, check the SID-bool service. What does a service look like? So first of all, you'll notice that a service is divided into two parts. There's like some separation between this part and this part. The first part represents the request part, and the second part represents the response. As we said before, it's not just like a message being transferred from a publisher to a topic, then to a subscriber. Here we have a request that passes through the service, and also we have a response. So it makes sense that the service would be divided into two parts. So here's the, we can just, call a service as a combination of messages. Which is true, because a service is like, it has a request message and a response message. So it's made up of two messages here. So we can say that a message is a subset of a service. Because we have two messages, so service has to be some union of these messages. So we have here on the request side of the service, we have a Boolean variable. And for those of you who are not familiar with programming, a Boolean variable is like a variable which basically says true or false. So it has either the value true or the value false, and the value true represents, guess what, true, and the value false represents false. Also on the response side, we have another Boolean variable, which is success. And here you can find a comment here. Also, we could find a comment there, here, or there, here, it doesn't matter. The Boolean data here in the request, you'll find that there is an example here, which is, he says, for example, for hardware enabling and disabling. And by that, the developer of this service, whoever he is, says that I could use this setBool service for hardware enabling or disabling. So let's just say, for example, in your robot, you have a camera, for example, and you don't need to use that camera all the time. So you need it only when, for example, you have some detection or classification application. So you need to turn on the camera for that application. Otherwise, you're wasting, for example, power or wasting some computational effort on the processing of the camera input, for example. Right, so I can use the service to enable or disable the camera, or enable or disable the service provided by the camera, for example. So when it comes to the to the response side, so we have a Boolean variable which represents the success of the operation. For example, let's just say you're turning the camera on. So if everything runs smoothly and the camera starts to produce some output, then I could deduce that the camera is running fine. So me, as a server, I have to inform the client that everything went smoothly. So I'll just print success, or I'll set the success variable to true in order to let the client be informed that everything is running smoothly. Otherwise, the client might have another say on the matter, or ask for another service or whatever. That's pretty similar to what happens in the real world. And we have a message here, which is a string. And for those of you, again, who are not familiar with programming, a string is a string. It's like a message that is written in using characters, using like real language. So I'm giving you like a statement on what happened. So I'm giving you some information, like for error messages, assuming that, for example, the success was set to false, then I'm trying to give you some insight on why things went south. For example, if the camera didn't turn on, so I might say that there's a problem with the hardware, for example. The camera is not connected. There's a problem with the power source. Anything that has to do with the failure of this task, whatever it is. So that's pretty much what a service is made up from. And this is not the only service. You can find other services with, associated with other applications. I'm just thinking of some application that, for example, is written in the comments here right away. You can think of any other applications that look similar to the application I've just mentioned. All right. So this is our service. So what I have to do now is to make my code compatible with the service or the server-client architecture. So first of all, instead of importing messages, we'll import services. So what I'm going to do here is I'm going to say standard services, and the object or the property I'm looking for is the service, which is this RV. And I'm going to use, for example, let's just use the setBool here. So I'm going to say import setBool. All right. So what about the rest? When it comes to initializing the node, it's just a node, whether it's a subscriber, a publisher, a server, a client, it's just a node. So no changes to that line. So when it comes to the ROS by the subscriber, of course that has to change, because I'm no longer a subscriber, I'm a server now. So guess what? I'm just going to type server, because I am a server. And actually, sorry, it's a service, not a server. Sorry. Well, sometimes when, naming conventions tend to, leave you in a state of confusion sometimes. So you don't have to worry about that. I usually forget that. whenever I'm working a project or something, you'll find some stupid error related to, for example, some naming convention like that, and it's pretty normal, right? So you get used to that. So no worries. Anyway, so ROS.service, and I'm gonna call my service, for example, let's just call. Oh yeah. By the way, in the old architecture, we used to leave a topic here, but now we are defining a service. So this is no longer a topic, so I'm gonna give it a name like test service, for example, or let's just call it something that would describe our application. In this case, let's just all right, let's just leave it test service. All right, so the data type here has changed. We're no longer using a message, we're using a service of the type setBool, so I have to change the type to setBool. All right, and then we have our callback. Our callback doesn't change, or not, not the callback itself, but the callback architecture or the callback philosophy doesn't change here. So I'll still have a callback, whether I'm a service or a server or subscriber. So we'll just have our callback here, and the difference is we might call this. Well, the callback does receive a message in this case as well, which is the request, but we can call it request instead of message. It is a message of sorts, but it is a request message, so let's just call it something like rec, short for request. That would be better and more informative. Right? And that's it. I'm done with the body of my server here. So let's just leave it like that for now. I think yeah, let's just leave it like that for now. I don't think we need anything else so far. All right, so that was pretty much our server. All right, let's elaborate some more on the callback, because the callback is empty. So what good is a server that does nothing? So let's just type something here. As I said before, our application will focus on some enable, disable request, for example. So what I have to do is I have to analyze this request. So I'm gonna, just check the request. All right. So what we have here is that the request is made up of two parts, which is, sorry, the request is here or not here, sorry. The request is made up only of one part, which is the data, and it's a Boolean, so let's just stick to that. So I have to check the data. So I'm gonna say if request, and not just the request, I'm focusing on the request to data. As we said before, there's some form of there are some forms of composite messages where a message is made up of several elements or several properties. So I have to pick the property that I need. And here we have a variable called data. So this is the part of the service that I have to focus on. So I'm gonna pick the requested data. So let's just say if it's true, what I'm gonna do. So I'll just enable my device, and despite the fact that I don't have an actual device here, we can just print success and imagine that there's some form of a device here that I've already activated, or some hidden line of code that I don't have to worry about now. So I'm gonna just say I need my response to be yeah, it was successful, and give a message which elaborates on the status or gives something more informative than just success Boolean variable. So what I need to do first is that I need to define some response, because my response is the thing that I need to deliver to the client. So I'm gonna type here response, for example. Sorry, response here, and of course my response has to be the type setBool. And here, there's something so strange with ROS when it comes to this point, is that I have to define some new data type called setBool response. And what's weird about that is that when we opened up, the services, there's just setBool. There's no service called setBool request, or there's no request on its own. It's just, it's implied that there is a request here. So why do I need to define a data type which is called setBool request? Well, sometimes, setBool response. Sometimes ROS, creates some services that do not exist as separate files, but they are generated by default once you create a service or create a server or a client or something like that. So it just generates this data type and expects you to use it. So I can't say that the response is of the type setBool, because setBool is like a very big service. It's a service made up of a response and made up of a request. So I need just the request part. I need to send just a request. So how you do that? I have to import setBool, because that's like the father of all the other parts, or the father of both the response and the request. And then I'm gonna use this implication here, like the setBool response, which is, like the child of the setBool that was generated by ROS without me noticing, for example. So that's what I'm gonna use. I'm gonna define the response, and it has to be the response variable. It has to be of the type setBool. Sorry, bool is capital B. And this is setBool response. So I define the response message of my service. It has to be defined that way. And I personally don't like that, and I find it pretty confusing, but hey, that's ROS. We have to use it anyway. So what I'm going to do is I'm going to focus on the parts of the response message. As we said, the response message is like a composite message. So it is composed of two variables. So I have to, change these properties. So the first property is response success. So I'm going to type here response success, and I'm going to give it the value true, for example. Sorry, because it's a Boolean variable. So it was successful. I did enable the device, and I have to print some message. So there was also a part called message here. Yeah, there's a string, so I'm gonna type a string. So how do you type a string? It's actually pretty simple. So I'm gonna say response. Sorry, I forgot an O. Dot message is equal to, you just have to use semicolons for that. So I'm gonna use 2 semicolons here. It is called a semicolon, right? I'm pretty bad at punctuation and stuff like that, but anyway. Alright, it's not a semicolon, it's just a colon, I guess. There's the parentheses, and anyway, those things, like those, whatever. So I'm gonna type a message called, for example, yeah, it's a code, right? It's a coding. Yeah, they're between codes, between whatever. I'm gonna type the device was enabled, for example. Yeah, just stick to that. The device was enabled. All right, and that's it. So what if the request data was false? That means like disable the device. So I'm gonna say else. And I'm just gonna say else, not else if, because, what is not true is naturally false. So I'm gonna say, for example, response dot success, and I'm gonna say true. It might sound a little bit unfamiliar to you. Well, the request data is false, so how is the success is true? Here I'm talking about the disabling of the device. So what you're saying, or what the client is trying to say, is I need you to disable the device. So I'm sending a false to the enabling variable or the enabling property. And what you have to do is disable the device and say that I succeeded at disabling the device. So the success of this message is true. And then I'm gonna type response here. So the response message will be the device was disabled. Sorry to say disabled. All right, that's pretty much it. That's what I'm gonna do. But I have to do something extra here, which is called a return. So when you have a function that has some output, this function has to return a value, has to return some message, has to return something. All right. When we used the callbacks in publishers or subscribers, you didn't have to actually return anything. You usually just printed something. All right. But here I just need to return this response. I'm obliged to return that response, so I have to use the return functionality, and I'm going to return the response. All right. So this return property is like a common property among all programming languages. Whenever you're just making up a function and you need to return some outcome of the function or return a result, you have to use the return keyword. All right, so we'll stick to that. And in order to make the code a little bit readable, let's just, comment everything. So first of all, let's just say create the response message here. And then we're gonna, example, say execute the task, and then return your response, which is pretty obvious. Doesn't need a comment even. Return your response. Right, and that's it. And here I'm gonna just say, for example, node setup. All right, that seems to be everything we need so far. So let's try to run the server. Right, so you can actually run a server. It's no problem. You need to run a server on its own because a client needs a server, but a server can work on its own and just wait for a client to issue some requests, and then it will deliver the response. But the client will not be able to, continue doing what it usually does without having a server nearby. So I'm just going to open a new terminal, and I'm going to open up my ROS core, which is the master here, and the ROS core has to be always available whenever I need to run some ROS applications. So I just have to have a ROS core. Whether you're creating publishers, subscribers, servers, clients, you have to have your ROS core operational. So what I'm going to do is I'm going to use the ROS run command. So I'm going to just say ROS run and the name of the package. So as far as I remember, it was server client or client server, something like that. So let's just get back to where we were before we moved on here. Alright, this is the Captain workspace, the SRC. Yeah, its name is client server. So let's just stay here for the time being. So my package name, client server, and then I'm gonna run the application known as server.py. Alright, I forgot to make it an executable. Too many permissions. Right, so I gave you the permission. So let's ROS run. Yeah, it's running since my terminal is like frozen. But we need to check whether it's actually there or not. So I'm just gonna open up a new terminal, and I'm gonna, I need to list my services. So I'm gonna use some command called ROS service.list, and it's pretty much similar to ROS topic list. So ROS service list, and there we have our test service. Here it is. The rest of the services are just like standard ROS services that have nothing to do with the code that I just wrote. Alright. So our server is running. So I'll just kill it for now, because we need to make our client code. So let's just, open the terminal here, for example, and let's touch client.py. Right, so we have our client application. And our client application here really does not look like a publisher. So it doesn't look like a subscriber either. It's kind of different, so we'll have to start it from scratch. We don't have to compare it to anything that we saw before. So there are some standard procedures like informing my compiler which ROS version I'm going to use. So I'm going to type user bin environment, and I'm going to use Python 3 as usual. And then I'm going to import ROS.py, of course, because it's all about ROS.py when you're writing Python and using ROS. And then I'm gonna, I need to import my standard services. So from standard services serve, I'm gonna import, well, I have to import, I have to import setbool, because it is the standard message or the standard service that I'm going to use for my application, and it is the service that the server uses, so I can't just ask for another service. So let's just stick to setbool. And as we said before, there are, some services or messages, or let's just stick to services because it's just service, that are implied here, or that are generated by default by ROS whenever you run such an application. So as we did with the request part, there must be some response part. Oh, sorry, I just, I defined a response there, so here I'm going to define a request. It's getting confusing, and, we need to work on the ROS architecture a little bit. Anyway, we have a setbool request, which was, as we said before, generated by default, and, it's like some hidden agenda that ROS uses. So first thing I'm gonna do is to initialize my node. So this is ROS.py.init node as usual, because as we said before, a node is a node regardless of its function. So I'm gonna call this node client, right? Just like the py file. Sorry, I forgot the code here. And then I'm gonna define a client object, and it is slightly close to the publisher in this particular point, because in the publisher we used to create some object as well. So I'm gonna, create a client object, and it's okay to have the name here client and the name of the Python file client, and to have an object called client, because this is a variable. It has nothing to do with the name of the file itself or the name of the node. So what might be troublesome is if you have two variables called client, but here all these client names are different in terms of, you know, the type of or the nature of its existence. This is a Python file, this is a name of a node, and this is a variable, so there's no problem at all. Alright, so what I'm going to use here is I'm going to type rospy dot. So for the server, we use the rospy.service here. We're going to use something called rospy.service proxy. And could have figured that out on our own, but it's called rospy.service proxy. For clients, for servers, you use rospy.service. Anyway, we call a service proxy and we define some arguments here. Well, the first argument, of course, is the name of the service. So it has to match the name of the service that we picked for the server. So this server is, doing a favor called test service. So we have to stick to that favor. I'm going to call it test service here. All right. And of course, the data type, which was agreed to be setBool. All right. So what I'm going to need to do here is that, as we said before, the client cannot execute its task without having a server nearby. And this is quite illustrated by this line I'm going to write now, which is called client, which is my object, and then I'm going to use a function of that object called .wait for message. Sorry, wait for service, not message. So it's a client.wait for service, and what this function does, it's a function, or it's a function property of the object client, because once you have a dot between an object and a variable or a function, you know that this function belongs to this object. It's like a trademark function that is specifically designed for this object, right? And the same thing goes for variables. Once you have, for example, a variable called client.variable, then you have to know that this variable is a property of that client object and not an individual variable and so on. All right, so we're going to say client.wait for service, and what this does, it's basically like rospy.spin, but for clients. What I'm telling the compiler here is that you have to freeze yourself here, or just freeze till a server is nearby or a server is active. So I can't execute the rest of the code without having a server. Right, so what I have to do now, assuming that the server already exists or the service is active, is that I'm gonna, issue some request. So I have to define a message of the type request. So I'm gonna say request is equal to a message of the type setBool request. setBool request. All right. So it might sound pretty confusing that request is a message, and well, it's a message just by the fact that it just, was defined to be a service. And well, it is pretty confusing, but here we define it as a message, which is a part of a service or a message of a service, and this is why it has the affiliation service despite it being a message of sorts. Right, so we'll just say request is equal to setBool request. So what I'm basically saying is that I'm going to define a variable called request, and this variable represents some data type called setBool request, which is a message basically, but is a message that is affiliated with a service called setBool. Right. So what I'm going to do next, what I'm going to do next is to set this, the value of this request, or the values of the properties of this request, because this, as we said before, sometimes a message is made up of too many variables. So we gotta check set bool, and we'll find that the request part just has a data entry. So what I'm gonna do here is that I'm just gonna change the value of that data property or data variable. Right, so I'm just gonna say request, or the data part of the request message of the standard set bool service is, let's just say I'm gonna enable the device, so I'm just gonna type true. Right. What I'm gonna do next is that I need to send that request. So in order to send that request, in publishers, we used the function publish. Here we're gonna use just, yeah, we're just gonna use the client object, and that's it. So I'm gonna say response, which is the response I'm expecting from the server, which has returned from here. This return statement will return the response here in this line. So the response is going to be equal to client, and this client must have the request here. So I'm gonna, pass the request to the server through this line. All right, and that's pretty much it. So, for example, in order for us to just visualize the outcome, I'll just say print response here, just to visualize what happened. Right, so let's just comment all these lines and review what we've done so far at the same time. So first of all, I initialize my node, so node setup here, and then I had to define my client, or define my client, and wait for service, or wait for the service, because we need a particular service. All right, then I'm gonna, create the create the request message. Right, and set its properties to either true or false, or maybe if we have another type of a service that has, other request data types, then I'm gonna, for example, if it's integer, then I'm gonna supply some numerical value, for example, and so on and so forth. So then I'm gonna receive the response and store it somewhere in a variable, for example. And then I'm going to visualize the outcome, so visualize here. So that's pretty much it. So what we need to do now is to run both the server and the client. So I'm just going to pick my terminal. This is a terminal created for the touch process. Yeah, the ROS score is still on, so just run the server first, because it's wise to run the server first before running the client, because we know that the client will get stuck at that line which is waiting for a service. So just run your server first, and then I'm gonna run my client. So ROS run client server package, and then I'm gonna run the client script. So, and give it a run. But actually, I forgot to make it an executable. As I said before, too many permissions. Right? Permission was granted. So let's run the client. And yeah, it basically printed what I needed to see. The device was enabled, so the success entry was true, and the message was displayed. The device was indeed enabled. All right? And that's how you create a client and a server. It's that easy, actually, but It is hard when it comes to the structure of the code itself, and you needn't worry about that. It's pretty confusing, and it's harder than publishers and subscribers when it comes to memorizing all the commands and all these details. Um, it's actually pretty cool because I forget them myself. And whenever I have to create a new client-server application, I have to like review all the parts that were included in the creation of this client-server architecture. And then sometimes forget commands, sometimes I forget lines. It's pretty normal. So you don't have to, stress yourself about it because this architecture is pretty standard, and you can just review it whenever you need to. But the application itself is going to be very simple. So basically, clients and servers are used for pretty standard applications. So you don't have to worry about forgetting some commands or forgetting some lines. You're just going to review it, or you're going to display, the terminal is going to display a couple of error messages, and that's it. And you're going to fix them anyway. All right. So this part is done. Right, so we'll have a quick summary on what we did today. We spoke about server-client architectures and how it's different from publisher-subscriber architectures. We also created a server-client package in order to, enable or disable a device, which is a virtual device in this case. It's not an actual device. And then we're going to speak about the usage criteria here. I mean, when to rely on a publisher-subscriber architecture and when to use client-server architecture. So basically, a client-server architecture is it looks much like, a function when it comes to programming languages. In case you're familiar with programming languages, a function is, some lines of code that you might use or might not use. It's just an available functionality that provides a service for you. What a client-server package does is basically the same thing. It's just a service that is, just sitting there waiting for you to issue some request. So it doesn't execute its task unless you issue a request. Unlike publishers and subscribers are usually used in applications where I expect this task to be running continuously and executing some task non-stop, whether I'm receiving that output or not, or whether the subscriber exists or not. Right. Also, a subscriber might subscribe to a topic. Even if the topic did not receive new messages, the subscriber is still linked to that topic. But when it comes to clients and servers, the client usually has some specific task that is not, like a permanent task or a continuous task. It's just like a hit and run task. So I have to issue a request whenever I need that task, like enabling a specific device. I'm not expected, for example, to enable and disable a device continuously. I'm just doing it whenever I need to in my application. So client server packages are like for hit and run applications, but publishers and subscribers are like for more permanent tasks, for tasks that are expected to run continuously, like, for example, your robot control, for example. A robot is expected to operate continuously and move its joints, for example, or move its wheels all the time. And even if it stops, still the control algorithm controls how it stops and uses the brakes or whatever. So a control task is expected to run continuously, and therefore it's wise to design a control node, for example, to be a publisher or a subscriber. For example, publishing control commands to your motors and subscribing to some sensory input that, or based on which delivering some control action. But when it comes to server client applications, it's just like more suitable for enabling or disabling something, triggering an event, something that is not expected to, happen a lot. Alright, so that's the usage criteria. So hopefully all of that made sense, and in the future when you get to design your own applications, you'll be you'll be familiar with both architectures, and you'll get to decide which one is more suitable for your application.